right, it's 7 o'clock. First of all, thank you everyone for coming in tonight. This is the second webinar presentation from the Sierra Club Capital Group. I am the local group chair for the Capital Group, Hua Huang. Tonight's program is Climate Crisis in North Carolina, featuring our very own Conservation Committee co-chair in the local capital group, Dave Anderson, and also NC State University undergraduate volunteer Colin Scanlon. So before we begin, I'd like to show some group announcement. For those who may be new to the Capital Group or the Sierra Club, just want to let you know that with the Sierra Club is still very much keeping an eye on monitoring the ongoing issue, not just on the COVID-19, but also on many of the racial issues that's going on across the country. To start with, just most recently, actually, Michael Broom, who's the Sierra Club Executive Director, had recently posted an article about how the Sierra Club is going to be much more intentional about being an anti-racist organization, starting with redesigning the leadership structure to make space for Black, Indigenous, and other leaders of color to have a say, have a voice in the Sierra Club. So that is a step forward, I believe. And some more about the Sierra Club. We are one of the oldest, largest, and most effective grassroots environmental group in the United States. And of course, we're seeking to improve ourselves going forward. But for now, majority of the issues involve addressing climate change issue and water pollution, fossil fuels, renewable energy, and the protection of forests and parklands. And the Capital Group is only one of the 12 volunteer groups in North Carolina. We have about 10,000 members and supporters, and we serve 11 counties in central North Carolina. And just a few updates on what's been going on with Dirty Fuels campaign. The Atlantic Coast Pipeline is canceled as of July 5th, but much more work still needs to be done because we still have the Mountain Valley Pipeline, and there's still the question of how how Duke Energy and North Carolina will clean up the pipes and the damages that was left behind from all the work that has already been done for the Atlantic Coast Pipeline now that is no longer functioning. So more to come on that. And with our Ready for 100 campaign, specifically locally in Cary, we'd like to let you know that there's an application for the Environmental Advisory Board and also other board positions that's due July 31st. We will share the link in the chat shortly after this announcement, so people who are in Cary who are interested in being a part of the process to make Cary a greener place, you can consider filing for the application. Furthermore, the Environmental Advisory Board meeting for Cary there's one happening on August 11th from 6 to 8 p.m. And also there's a neighborhood zoning meeting on August 12th from 6:30 to 8 p.m. If people are interested, the links will be shared in the chat shortly. And for those who are following up on the issue with the RDU Forest and Olmsted State Park, otherwise known as the Wake Stone's proposed quarry issue, most recently, the Department of Environmental Quality, or DEQ, had just sent a 7-page letter to Wake Stone Corporation with a list of environmental concerns that they need to address. All of these actions, the pipeline, the quarry issue, we can go as far as we are right now. It's just in no small part thanks to all the people who have submitted comments, who've been present to let our government agency know that we care about the environment and our home. So thanks to everyone who participated in this process. And a brief note about political update. As you know, with the election coming up, we need more volunteer helping out with fundraiser, donor outreach and endorsement, and getting people out to vote. If you're interested in helping out with that, we can share the contact information for you to send emails for those who express interest in volunteering. And some upcoming events. Most of our events right now are happening online. I highly recommend people to check out our meetup site for updates on the events. So August 4th is when we will have the Capital Group Executive Committee meeting. Everyone's welcome. It's open to all. Just visit our meetup for updates when we have the Zoom link set up. And on Thursday, the Winoka group of North Sierra Club is having an event on plastic problem solution and how to recycle right. If you're interested, this is the meetup link that you can find out more about how you can register for the event that's coming up. On the 11th of August, the Capital Group Conservation Committee will have their meeting, same as the XCOM meeting. Visit our meetup for more updates. And on the 18th, Sierra Club is planning to host a panel on agriculture in urban counties, more specifically centered on the triangle. We're still very much putting together logistics, so if you're interested, more information will come. If you visit our meetup site, you'll learn more about when these events will be updated with more information. And without further ado, I'd like to bring you guys to tonight's program, Climate Crisis in North Carolina, introducing our speakers, Dave Anderson and Colin Scanlon, who has spent much of the past couple of months putting together, doing the hard work of putting together all the slides just for tonight's events. If you don't mind, please submit all the questions you have to the Q&A, and we will be sure to address them. Thank you, and I will hand it off to Dave and Colin.
Thank you, Wah. I'm David Anderson, a volunteer for the Capital Group of the North Carolina chapter of the Sierra Club. My background is in science and engineering. I have a BS degree in physics as well as electrical engineering, and also an MS in industrial engineering. I worked for 25 years in the semiconductor industry, most of which was spent building models and using computer models of factory operations. I retired in 2013 and have spent time since then learning about climate change. This webinar has been developed by myself and Colin Scanlon, a North Carolina State student and summer intern with the Sierra Club, and other Capital Group volunteers of the Sierra Club. We have many slides to get through, so please hold all your questions till the end for the Q&A session. You can enter them in the Zoom chat, which we will go through at the end, and I also ask you to please turn off your video until we get to the Q&A session. Okay, quick overview of what we're going to talk about tonight. First portion will be about the climate crisis. What is the history of the climate crisis? How is it impacting the United States, and also specifically, how is it impacting North Carolina? We'll review Governor Cooper's Order 80, Executive Order 80, talk about some of the things that it has triggered and required the state government to do. And then also we'll end up with a portion talking about what's happening now, what is happening in North Carolina to address the climate crisis, what is the Sierra Club doing, and then what can you personally do. As people across the country protest in defense of Black lives, the Sierra Club recognizes the need to dismantle systemic racism in the United States and within our own organization. We must reckon with how white supremacy, both past and present, has shaped our institutions and do the critical anti-racism work necessary to repair the harm done. The environmental movement does not exist in a vacuum, and it is our responsibility to use our power to help abolish systemic racism, which is destroying lives, communities, and the planet. The COVID-19 crisis has not passed and continues to disproportionately harm Black, Indigenous, and Latinx people and other communities of color. The pandemic has revealed how communities hardest hit are often the same communities that suffer from high levels of pollution and poor access to health care. The fight for environmental justice cannot be separated from the fight for racial justice. Here are some acronyms that we will be talking about over the evening. GHG stands for greenhouse gases. CO2 is carbon dioxide. CH4 is methane. GTCO2 is gigatons of carbon dioxide. ppm is parts per million. And BIPOC stands for Black, Indigenous, and other people of color. Talk a little bit about weather and how that differs from climate. Weather is what's happening now. It's a short-term state of the atmosphere over hours to days, highly variable on a day-to-day basis for most climate zones. It's defined by parameters such as temperature, air pressure, humidity, cloud cover, types of clouds, precipitation rates, storm systems, and etc. Whereas climate is what you would expect for a particular location and time of year. And it's defined by a 30-year average and depends on time and location. So the example or comparison is you expect cold in Minneapolis in January and you expect warm and humid in Miami all the time. So let's look at some periods of time over the last few years to see how these parameters have been changing. This short video shows how the temperature has been changing over the globe for the last 140 years relative to the average of a 30-year baseline period from 1951 to 1980. You can see how the world starts off mostly blue, stays that way until about the 1920s, starts to become more yellow until about the 1940s, stays constant or slightly more blue again up to about the 1970s, and then really starts to show the warming of the most recent 40 years. So except for the beginning, there seems that there have been no long periods of stability. And some of the statistics about temperature, the first half of 2020 is now the second warmest January to June period on record, second only to 2016 and warmer than 2019. 2019 on a whole was the second warmest year on record after 2016, which was the warmest due to a very strong El Nino effect. 2013 to 2019 had 7 of the 9 warmest years on record, and 2001 to 2019 had 18 of 19 warmest years on record. Now we'll look at a graph showing the average sea level and how it's been changing since the 1880s. Sea level rise is caused by thermal expansion as the ocean warms, and also the melting of land ice from the glaciers and Greenland and Antarctica. Here's a graph showing what's been happening to the Arctic sea ice over the last 40 so years. You can see that there's a significant trend downward, and if that trend continues, sometime after 2045, there will be no sea ice during the September minimum, which is when the sea ice is at its lowest extent. Sea ice forms at the surface of the sea, and the volume of the ice is greater than the volume of the water it formed from. That's why it floats. The volume of water displaced by the sea ice is the same as the volume of water added to the ocean when sea ice melts. As a result, the sea level does not change when sea ice melts. This can be demonstrated with a glass of water containing several ice cubes. As the ice cubes melt, the level of the water never changes. The reason to be concerned about the loss of the sea ice is that it is part of the snow-ice albedo positive feedback that leads to more warming, and it also has resulted in habitat loss. Okay, so we've seen, based on temperature, sea level, and Arctic sea ice data, that something is changing. The climate is changing is the answer to that question. What is changing? It's the climate. And basically climate change is defined to be changes in weather patterns or conditions persisting over many decades. And it is an indicator of change is the changes in temperature, increases in magnitude and frequency of severe weather patterns, rising sea levels, decrease in heating and cooling needs, and decrease in Arctic ice coverage. So what is happening? How fast will it happen? Will it happen the same everywhere, or will there be regional differences? One of the ways to know what is going to happen is to study what has happened in the past. The Earth's climate history is written in these archives. Pollen, leaves, small-shelled animals all leave remnants that we can use to determine climate conditions and changes in the past. The Earth's climate has always been changing when looked at a geologic timescale. During the years 4.567 billion years, there have been periods when the surface was nearly completely frozen over. Other periods have been a hothouse with tropical conditions found at or near the poles. For the most part, these periods took thousands to millions of years to evolve, while other periods show surprisingly rapid change. What is unique about now is that the timescale for change is taking place over a mere couple of centuries. Also, up to now, all of the changes have been driven by natural forces, while today's changes are being driven by human activities. An important event took place 2.4 billion years ago when cyanobacteria in the oceans developed photosynthesis and started changing the composition of the atmosphere with the addition of oxygen. This event enabled the subsequent development of multicellular forms. The major constituents of the atmosphere have been relatively stable since this event. So what are the factors influencing climate change or climate crisis? Natural climate factors include Earth's orbital parameters, solar output of the sun, like tectonics and volcanism. Human factors include burning fossil fuels, land use, and other chemical pollutants. As the greenhouse gases accumulate in the atmosphere, they form a blanket that cause more warming. The extra gases hold the heat in, and then the atmosphere warms up and emits that energy back down to the Earth, warming the Earth's surface. CO2 is the most important of the human greenhouse gases. It stays in the atmosphere for a very long time, centuries or longer. Methane is the next important, and it is oxidized in the atmosphere relatively quickly, and it lasts about 12 years. Nitrous oxide is the third most important, and it remains in the atmosphere for about a century. And there are many other gases that are much less important on an individual basis. This graph on the lower right here shows the increase in annual emissions of greenhouse gases from 1970 up to 2010, and you can see that there's a steady trend all the way up. Another thing that we have learned about the climate is that there are feedbacks, and we'll talk about some of these in a minute. An example of a positive feedback that we have all most likely experienced is what happens when the volume of a PA system has been turned up too high and ambient noise is amplified and then output through the loudspeaker. If the microphone is too close to the loudspeaker, the sound is then fed back into the amplifier, which makes it louder still. The result is that very quickly the loudspeaker will be screaming at full volume. An example of positive climate feedback is the melting of snow cover, the snow and ice albedo. Albedo is a measure of the reflectivity of a surface. As air temperature increases, snow cover melts. The area previously covered by the melted snow absorbs more solar radiation than it did while covered by the snow. The increased absorption helps to warm the air further, which results in more snow cover melting as well. So you have warming and melting going on. The behavior continues until the snow is all melted or some other effect occurs which returns the system to the original state. These feedbacks can have the effect of amplifying the perturbation to the climate system that humanity is causing. The issue with these feedbacks is knowing when they will kick in. Certainly some of them have already started, and the example would be the sea ice in the Arctic. Others may not have begun yet, although we can't be sure. Another thing that we've learned about the climate is that there are these things called tipping points where certain states can change quickly and then stay gone forever. So loss of sea ice, permafrost melting, methane ice melting from the ocean floor, mega droughts, mega fires, tropical forest collapse, all of these things may have tipping points involved. And once gone, it's gone for much too long to matter to humans. There is evidence that all of these tipping points have been tripped in the Earth's climate. Some of them show evidence of happening now. Here's a video of what's happening in the Arctic. This is a frozen lake, and we see something bubbling up in the center of that open water, and that turns out to be methane. There's methane contained in the lake floor, and it's melting and being emitted up to the surface and going into the atmosphere. The permafrost and methane ice tipping points are related to reservoirs of potent greenhouse gases which can drive positive feedbacks. And there are literally thousands of gigatons of CO2 and or methane that's buried in these reservoirs. How do we know it's us? This is a graph showing the history of CO2 in the atmosphere going back to 800,000 years, and these are measured from air bubbles trapped in the ice of Greenland and the Antarctic. With the exception of this one small area here, the concentration never goes above 280 parts per million for the entire horizon. This red arrow over on the upper right here is drawn to scale, and it shows where the year of 2019 was in terms of CO2 concentration. We averaged 407 parts per million. And earlier this year, on May 25th, we had the highest record ever measured at Mauna Loa, and they measured 418 parts per million. How do we know it's us? This is a graph showing the annual emissions going back to 1750. And you can see that there's a very slow rise up to about 1950, and then all of a sudden it really starts to take off. And this is what has been referred to as the Great Acceleration. In terms of annual emissions, China is currently #1, the US is currently #2, and the European Union is currently #3. But in terms of cumulative emissions, the United States is #1, Europe is #2, and China is #3. So what things could happen as a result of what's going on? Certainly we have been experiencing some of these at the beginning of this list currently. Warmer, more hot days. Warmer nights, fewer cold days. These are all happening now, and we have experienced these in North Carolina. Stronger extreme weather events more often, thunderstorms and hurricanes, and certainly we've had some of those in the last few years. Sea level rise, tidal flooding of coastal cities and saltwater intrusion. This is happening worldwide. Problems in Miami, they're having tidal flooding almost on a monthly basis, and all along the North Carolina coast, the sea level has been measured to be rising. Droughts, floods, water shortages, wildfires are all something that are happening more often. Everybody remembers what was going on in Australia last winter when they were having their summer. Crop failures and famine are a function of droughts and floods and other disasters. Migration of all species. They're moving poleward, away from the heat towards the cooler climates if they can. Unfortunately, the trees can't move quite as fast as some of the other animals. So we're experiencing loss of ecosystems and habitats and species extinction. We're experiencing more pests, ticks, bugs, spiders, and etc. The oceans are acidifying and the coral reefs are dying off. Economic disruption, war, collapse of civilization, and mass extinction are all distinct possibilities if we do not get our emissions under control. So looking ahead, this is a what-if graph showing what would happen if our emissions grew with the economy of today. The deep red line assumes an annual emission growth rate of 6.8%, and the lower, lighter red line assumes a growth rate of 3.5% up to 2050, and then 2% past that point. I'm not an economist, so I don't really know if it's possible for the economy to grow at 6.8% for the entire horizon that we're looking at here. And the other problem is I don't know, or I'm not sure if there's enough fossil fuel to support that growth. But the good news about this graph is that, if you can call it that, is that the oil reserves will only last for about another 50 years, while the coal reserves may last until the end of the century. The CO2 content of the remaining energy reserves is estimated at 2,800 gigatons. And up until now, we have emitted approximately 2,200 gigatons. So unless there are large undiscovered reserves yet to be found, humanity's cumulative emissions would be limited to approximately 5,000 gigatons. The great concern about this is due to the feedbacks and tipping points we reviewed earlier. The amount of gigatons contained in those reservoirs are in the tens of thousands. And the concern would be if those things started to kick in and we ended up emitting enough greenhouse gases that we would be exceeding this horizontal line here. That horizontal line is a reference to what happened in the past in terms of a mass extinction that was experienced 56 million years ago. That mass extinction occurred during this event that's called the Paleocene-Eocene thermal maximum. As I said, it occurred 56 million years ago, somewhere between 7,500 and 25,000 gigatons of CO2 equivalents were emitted over 15 to 20,000 years, warming the Earth by 5 to 8 degrees C, and CO2 levels were somewhere between 1,000 and 2,000 parts per million. It took over 100,000 years to recover, and it's considered to be a close analogy to the current situation. The impact on the ocean was severe. Temperatures at the poles was measured, expected to be 70 degrees, and at the equator almost 100 degrees. The ocean's acidified, and so no shell formation was possible, so all those critters that make shells died off. And there were no ice at the poles, so there was significant ocean level rise, and Raleigh would have been on the coast. And in some cases, in some areas, the ocean circulation shut down and the oxygen in the oceans were consumed, and it became anoxic. And it created the deepest sea level mass extinction in the last 93 million years. And that's not the worst of it. These are the 5 major mass extinctions that have been found to have occurred. The extinction of a large number of species within a short period of geological time, thought to be due to factors such as catastrophic global event or widespread environmental change that occurs too rapidly for most species to adapt. The number of species lost is greater than 60%, up to potentially 90%. The first 2 occurred in terms of rapid global cooling, and perhaps these are when the ice covered or nearly covered the entire Earth. The next 2, Permian and Triassic, deal with rapid global warming, high increase in methane and CO2 in the atmosphere, oxygen removed from the oceans, desertification of the land was experienced. And the final one here is the one that everybody's familiar with, that killed the dinosaurs, which was a result of an asteroid impact. But there is a lot of evidence indicating that there was a fair amount of volcanic activity that took place prior to that. So the Earth was already stressed to some extent before that strike took place. During the Permian, at least, and perhaps the Triassic, ocean circulation shut down and the ocean went stagnant and anoxic. Anaerobic bacteria and algae take over and start emitting vast quantities of hydrogen sulfide, which is highly toxic to our current oxygen-based form of life. So the climate system is an angry beast, and we are poking it with sticks. This is a quote from Wallace Broecker, an American geochemist. He gave early warning of the planet crisis if humans continue to spew carbon dioxide in the atmosphere. He published a landmark scientific paper in 1975 that asked in its title, Climactic Change, Are We on the Brink of a Pronounced Global Warming? So obviously we cannot allow this kind of a disaster to take place. Scientists have known about this possibility for many decades. Earliest predictions of global warming go back to the early 1900s when Savante Arrhenius first calculated how much warming would occur with a doubling of CO2 in the atmosphere. The UN formed the IPCC in the late 1980s, and that body has been responsible for reporting on the science, risks, and mitigation of climate change. The special report was published during 2018 detailing the impacts of global warming of 1.5 versus 2.0 degrees C. There are meaningful differences between these two levels of warmings, with 1.5 being much more tolerable than 2.0. Climate modelers have estimated the allowable emissions that will result in different levels of warming at a given likelihood of success. The cumulative CO2 emissions since pre-industrial era to the end of 2017, as I mentioned before, are approximately 2,200 gigatons. During 2017, annual emissions were 42 gigatons. I should note that none of the non-CO2 greenhouse gases were included in this analysis, nor were any feedbacks or tipping points included. So the remaining budget at an 84% chance of success is 290 gigatons, which at 42 gigatons per year lasts 7 years. But we are already 2 years into that 7 years, so we basically have 5 years left to get our emissions down to zero before we will lose any chance of keeping warming to less than 1.5 degrees C. If we want to take some more risk, we can increase the chance or decrease the chance to only 50%, which is basically a flip of a coin. And that increases our emissions up to about 580 gigatons, which results in 14 years. Again, we're 2 years into that 14 years. Speaking next will be Colin Scanlon, who will start with how the climate crisis is affecting the U.S.
Yeah, so now we're just going to take a look at how climate change has impacted us right here in the United States. So the United States has already seen a rapidly changing climate with historically high temperatures, drastic changes in sea level, and increased extreme weather events. The most recent National Climate Report has documented many of these changes, including the annual average temperature in the United States increasing by 1.2 degrees Fahrenheit over the last few decades, and 1.8 degrees Fahrenheit relative to the beginning of the last century. Extreme rain events have increased in frequency. The season length of heat waves in many U.S. cities has increased by over 40 days since the 1960s, and warmer and drier conditions have contributed to an increase in large forest fires over the past several decades. Without substantial and sustained global mitigation and regional adaptation efforts, climate change is expected to cause growing losses to American infrastructure and property and impede the rate of economic growth over the century. Many of these observations will only continue to increase in magnitude if climate change goes unchecked. In addition to the impact on human infrastructure and our natural environment, climate change is expected to dramatically harm human health and well-being. Some of these include high temperatures in the summer being linked directly to an increase of risk of illness and death. Rising air and water temperatures and changes in extreme weather and climate-related events are expected to increase exposure to waterborne and foodborne diseases affecting food and water safety. Climate change can allow the occurrence of tropical diseases and pandemics to increase, and warmer temperatures, changes in precipitation, and high CO2 concentrations can also increase exposure to pollen allergens. As the Trump administration has taken a firm stance against climate science and environmental regulation, much of the fight against climate change has become an issue for local governments to overcome. Prior to 2016, the federal government had participated in UN climate change discussions, supported scientific studies through NASA, NOAA, and other organizations, was a signatory to the Paris Climate Agreement, and enhanced the Clean Air Act to include CO2 as a pollutant. Shown on the slide are some of the over 150 actions that the Trump administration has taken to roll back environmental protections. The Trump administration has plans for another 150 more actions that they will try to push through over the next 6 to 7 months. Some of these actions have been implemented, others challenged or blocked through court cases. And now we're going to go even more locally and look at the climate crisis just within North Carolina. But when discussing climate change, we must take time to evaluate the racial and geographic implications that have made the consequences of climate change disproportionately impact minority and low-income communities. The same conditions that have allowed climate change to exist are the same that value some lives over others and make up the same systems that perpetuate income inequality and white supremacy. As a result, climate change also disproportionately affects Black, Indigenous, and other people of color and low-income communities. For example, the Dakota, Atlantic Coast, and Keystone pipelines were built or planned to run through Indigenous and low-income communities. The Atlantic Coast pipeline construction, planned to run through the Indigenous Lumbee tribe's land, has been stopped due to increased pressure and protests brought on by activists. Additionally, air pollution exacerbates COVID, making people of color more likely to both live in polluted areas as well as die from COVID. In response to the Warren County sit-ins, the U.S. General Accounting Office commissioned a study that found that 3 out of 4 hazardous waste landfills were located in communities where African Americans made up at least 26% of the population. Even so, environmentalism has often been predominantly white and failed to address environmental justice concerns. Without addressing racism and environmental injustice, environmentalism and climate justice can never prevail. Now, even just within North Carolina, we have seen drastic changes in climate change caused by greenhouse gas emissions. We've had a 1 degree Fahrenheit increase since 1895, rapidly rising sea levels across the eastern coast, and the length of the freeze-free season has already increased by nearly 2 weeks. Like much of the United States, we expect to see drastic increases in sea level, summer heat, precipitation, hurricane frequency and intensity, drought, and flooding. Additionally, we also expect to see increases in wildfires, ecosystems and habitat loss, saltwater intrusion, public health degradation, and population growth and other hazards. Here we see some of the pictures of North Carolina following Hurricane Florence. In the upper left, we see flooding in Trenton, North Carolina. In the lower left, we see the return period for hurricane strikes. You can note that North Carolina has a strike probability as great as southern Florida. In the upper right, we see hog farms flooded, and there are hundreds of these scattered across the eastern seaboard of North Carolina. And in the lower right, we see the outflow of hog waste and other debris from the rivers, streams, and into the Atlantic Ocean. North Carolina has begun the process of passing specific actions and legislation to prevent future warming. Some of these include Executive Order 80, issued in October of 2018, the renewable energy resolutions passed by local governments, Duke Energy retiring coal power plants and replacing them with methane-fired plants, and installing solar panels across the state. It's important to note that Duke has been much slower to phase out coal and greenhouse gases in North Carolina than in any other state they have monopoly over. And they have also been tirelessly striving to put pipelines through the state to transport natural gas and much of it to be exported. Now we're going to take at exactly what Executive Order 80 was. The Executive Order 80, issued almost 2 years ago, lays out a series of goals to be accomplished by 2025. These include reducing greenhouse gas emissions to 40% below 2005 levels, increasing the number of registered zero-emission vehicles to at least 80,000, and reducing energy consumption per square foot in state-owned buildings by at least 40% from fiscal year 2002 to 2003 levels. Executive Order 80 also creates the Climate Change Integrity Council to help the cabinet agencies work together to achieve those goals. There are specific directives for the Department of Environmental Quality, Transportation, Administration, and Commerce, and general directives that apply to all the participating cabinet agencies. As part of Executive Order 80, there have been several plans created to achieve the goals laid out in the order. For example, the North Carolina Clean Energy Plan, created by the Department of Environmental Quality, outlines its primary goal to reduce electric power sector greenhouse gas emissions by 70% below 2005 levels by 2030 and attain carbon neutrality by 2050, along with the steps necessary to do so. North Carolina's ZEV plan, created by the Department of Transportation, is aimed to establish interstate zero-emission vehicle corridors, increase the installation of zero-emission vehicle infrastructure, and outline best practices for increasing zero-efficient adaptation in North Carolina. This will be done through increases in education, convenience, affordability, and policy. The North Carolina Motor Fleet ZEV plan is focused on the inclusion of ZEVs in North Carolina's agency operations and motor fleet, and the Climate Risk Assessment and Resiliency Plan acts as a framework to guide state action and focus the state's attention on climate resilient actions and addressing underlying stressors such as the changing climate, aging infrastructure, socioeconomic disparities, and competing development priorities. In addition to these plans, there were several assessments made by Executive Order 80 to provide updated statistics on greenhouse gas emissions and energy and water use to evaluate the progress made. Now, where has North Carolina come 2 years after these orders? So far, we've obtained a greenhouse gas reduction of 26.1% through 2019. There have been 9,614 all-electric cars registered as of August 31st, 2019, and consumption per square foot in government buildings has decreased by 28% as of 2018. When looking at all economic sectors across North Carolina, we can see that electricity and transportation account for the vast majority of greenhouse gas emissions, producing 67% combined. It's important to note that all three goals laid out in Executive Order 80 primarily focus on these two sectors, as they are the primary obstacle in reducing emissions. Here we can see a breakdown for electricity generation by type. Since 2005, coal generation capacity has been reduced from 61% to the total of 27%. However, natural gas has increased from 3% to 30%. Unfortunately, in the same time, solar has only increased from just over 0% to 5%. Here we can see the progress made on solar installation in North Carolina. It is important to point out that the graph has an incomplete set of information for 2019. The 2019 installations were estimated to be between 1,000 and 1,250 megawatts in capacity total. Here is the Sierra Club's Ready for 100 campaign that has worked with Climate Solution Coalition, NC Warn, and 350.org, and others to get local governments to set goals of 100% clean energy by 2050 or sooner. Here we have a list of North Carolina cities, towns, and counties with clean energy resolutions. Not all of these are 100% plans, but most are. So now, what is the Sierra Club doing? Here we have some of the guiding principles that have been adopted by the Sierra Club in 2014. They include be inclusive, emphasis on bottom-up organization, let people speak for themselves, work together in solidarity and mutuality, build just relationships among ourselves, and commit to self-transformation. The Sierra Club is also committed to many programs aimed at addressing climate change and educating people about climate science. These include the Ready for 100, as we've already talked about previously, where we're asking mayors, CEOs, religious leaders, principals, civic and community leaders, parents, and students to commit to solutions that help us achieve 100% renewable and just energy across the United States by the year 2050. Over 160 cities, more than 10 counties, and 8 states across the U.S. have goals to power their communities with 100% clean, renewable energy. In total, over 100 million people now live in a community with an official 100% renewable electricity target. It's also Beyond Coal, where the Sierra Club is uniting people across America to replace our dirtiest energy source with the future beyond coal. There's also Beyond Dirty Fuels, where we're fighting polluting companies head on to protect our health and the places we love from the reckless expansion of dirty, dangerous fossil fuels. And Climate Parents, a diverse national movement of parents and families mobilizing for bold, clean energy and climate solutions at neighborhood schools. In addition to those programs, we also have the Clean Transportation Program, which is working to ensure that we all benefit from a 21st century clean transportation system with access to cars, trucks, and buses that rely on little to no oil, and to clean public transit and other local clean transportation solutions that center equity and justice. There's also the Clean Schools campaign. With this campaign, we train, empower, and organize youth to run effective campaigns and develop leaders for the environmental and climate justice movement. And the Sierra Club is providing handbooks, toolkits, and support and guidance for local efforts to move our school systems towards 100% clean energy. Finally, there's the Sierra Club Student Coalition, which is a network of high school and college-age people from across the country working to fight for climate justice and protect the environment. Now, what can you do as an individual to help fight the climate crisis? You can urge your local, town, city, county, and state officials to enact renewable energy plans that quickly transition away from fossil fuels. You can oppose the use of fuels that result in CO2 and/or methane emissions of any kind, including so-called renewable fuels. You can also support advocacy groups like the Sierra Club and 350.org. Additionally, you can educate your family, friends, and neighbors about the climate crisis. There are also many personal actions that you can take to aid in the fight against climate change. You can vote for candidates that support protecting the environment and those that will enact changes to address and mitigate the climate crisis. You can also educate yourself about your carbon footprint and how your actions may affect climate change. And you can use and waste less water and electricity. This involves adapting energy-efficient measures, buying energy-efficient appliances, and even installing solar panels within your own home. Fighting climate change can also be a daily task. When traveling long or even short distances, be sure to combine trips, take less trips, and carpool. Use public transportation, bikes, or walk whenever feasible, and purchase smaller cars, hybrids, or electric vehicles. This can also be in the things that you eat every day. Eat less meat, eat leftovers, avoid plastic packaging, and compost organic waste. Clothing production and manufacturing is another large use of water and energy. Purchase less whenever possible, or purchase from secondhand shops. Donate or sell your old clothing or appliances rather than throwing them away, and always work to be an enlightened consumer. To summarize what we've talked about today, climate change is happening, and it could be much worse if we take insufficient action. Time is running out quickly. We know what to do. We must find the will to take action. We have a massive job ahead of us, and it will take all of us to get it done.
Okay, great. I think we got it.
Yeah.
Thanks, David and Colin, for the presentation. If it's all right, I'd like to open the floor up for Q&A sessions. I did note that there's a couple questions that's posted on the chat. Let me bring this back on. So one question from Fika is, isn't melting of an iceberg contribute for the sea level rise? May you explain? Actually, let me just bring this back so that we can have Dave or Javier or Colin, would you like to explain about the sea ice melting issue?
Yeah, I can explain this one. So I guess it's important to note that there are two different things when talking about like ice melting, and one of them there's sea and land ice. So sea ice is normally just ice suspended in the water, and land ice there are just ice structures on land, but those also include things such as glaciers and large ice sheets. So when looking at this, the sea ice depicted in this graph is only the ice that's just suspended in the Arctic. It does not include glaciers and other ice sheets. And so what happens is that the sea ice displaces the exact same amount of water as it will fill up when it melts. And so the sea level doesn't rise from sea ice, but land ice, like large glaciers and ice sheets, do contribute to sea level rise, as those don't displace the same amount of water as the volume of water that they produce when they melt.
Hey, thank you for that explanation, Colin. Does anyone have anything to add? If not, I'd like to move on to the question on the Q&A feature. First question we have here is from Siladitya. It's from Siladitya is from Maryland and has two questions about North Carolina. One, since these nuclear plants are aging and will need to be shut down in the next 10 to 20 years, what is the plan to replace this carbon-free energy? Two, also, how much concern is there about the safety of older plants if their life is extended, especially given the vulnerability to hurricanes in the state? Who would like to help address this question?
Yeah. Well, this is Harvey.
Go ahead.
Yeah. I can't answer all of that, and then I'm not an expert on the nuclear power plants, but in terms of replacement, Duke Energy's current plan is to build a lot of gas-powered plants. There's some hope they were talking about moving a little bit away from that possibly in their next long-range plan called the IRP, Integrated Resource Plan. So we're watching that very closely. What will come out in September is a new plan. We and other groups have been lobbying that instead of additional gas-fired plants, which don't really solve the problem, is that Duke should be focusing on more solar and energy conservation instead. And that the demand really hasn't been going up significantly. It's been pretty flat over the last 10 to 20 years. And that we can meet that need. Solar, along with battery storage and renewable energy, energy efficiency, can supply enough electricity for our needs.
Okay, thank you for the explanation, Harvey. If you would like to ask for further explanation or clarification, please feel free to continue adding to the Q&A feature if you do. Okay, moving on. Next question is from William Blank. What specific actions or activities have local towns like Raleigh, Cary, and Apex done to move toward 100% clean energy? Who would like to answer to that?
Again, this is Harvey. Again, I can just say a few words about that. We have gotten 100% clean energy resolutions in Apex and Wake County. Cities like Raleigh and Cary haven't adopted 100% clean energy plans, but they do have actions underway, recommendations in Cary by their environmental advisory board to set some goals for reducing carbon and greenhouse gases. And they're getting ready to name, I think, some work groups that will then begin planning out implementation. Raleigh has, supposed to be by the end of this year, they have involved the community and a lot of stakeholders in developing a climate action plan. So hopefully we'll see progress on that by the end of the year with actual measures and plans to do things that will actually move us in that direction.
Right, thanks. So next up we have Kathy Buckley. With methane leakage, it's not the frack gas worse from a climate point of view than coal. Certainly coal is worse from a pulmonary perspective.
Yeah, well, I'll try to give an answer for that. This is Dave Anderson.
Sure.
Yes, in terms of the warming due to methane, methane is a much stronger greenhouse gas than carbon dioxide is. It doesn't last in the atmosphere nearly as long though. So it's a little bit of a fuzzy thing. Certainly in the short term, yes, methane leakage is bad. Although the pollution due to the coal, burning of coal, beyond just the CO2 that you get, is probably outweighing that to some extent. And it is better for us, I think, in total, to shut down the coal plants as quickly as we can.
Yeah, and another thing to add to that is that the greenhouse warming potential for methane is roughly like 25 times worse than for carbon dioxide, but the emissions are a lot lower when using natural gas. But the leakage in certain cases, depending how bad it is, can essentially neglect the advantage of using it over coal. But it's just, if it's done well, it's very advantageous to use instead of coal-fired plants. But when mishandled properly, and especially when traveling long distances, such as like pipeline transportation, that's when you risk methane being a worse alternative to coal.
Yep. So let's see. Next up, we have Louis Goodall. What about the GGE of substances that last much longer than methane? I'm not sure if someone can elaborate what GGE is.
Yeah, ask him to clarify.
Yeah. Louis, would you be able to, you could just mention in the chat or in the Q&A what GGE is? That would be helpful.
Greenhouse gas emissions.
Okay, greenhouse gas emissions. Okay, I see. Okay, so what about greenhouse gas emissions? Got it. Thank you.
Yeah, there are other substances that last longer, but in terms of impact on warming, you know, the IPCC publishes a pretty good sized table, and we can take a look at it if you want. There's a whole slew of different gases that are listed there. So why don't you go to slide view and we can pick that out.
Sure. Which slide do you have in mind?
All right, let me find it. Go on to the next question and I'll come back.
Okay. Actually, I want to follow up from Louis has the next question of, can we identify who is, I guess, committing to the greenhouse gas emission and stop it? Did you catch the question? Whether or not we can identify who is doing the greenhouse gas emission and halt it is the question.
I'm sorry, I had to go check. So go to slide 68.
All right.
So this is a table of the greenhouse gases from the working group 1. It's the 5th assessment, listing the chemicals over on the left, and then the concentrations measured in 2011, 2005, and then the radiative forcing 2011, 2005. Radiative forcing is basically a measure of how much warming is this gas causing in the atmosphere right now. So you see all these. Unfortunately, this table doesn't have the lifetimes. I don't think I have a table in our presentation that talks about the lifetimes of these things. Some of them may be longer. A lot of them do get consumed or oxidized as they spend time in the atmosphere. So we really need to know more specifically which ones you are interested in before we can answer that question.
All right. And next we have the question from Leanne Poland. Will there be wind turbines used in North Carolina renewable plan, perhaps turbine off the coast? Who would like to answer that?
This is Margaret, Sierra Club. I'm typing in an answer to Lee because there's a news article that I'm going to share about North Carolina back in May taking the first steps toward an offshore wind study. It's a request for proposals to analyze the state's ports and manufacturing supply chain. It's sort of a very early step toward studying how to set up offshore wind for North Carolina. And so it does look like that's something that the state plans to implement. So I will fully answer that question with the link in the chat. I'm sorry, in the Q&A box.
Just to add a little, this is Harvey Richmond, just to add a little bit to that, my understanding on there have been studies in the past, and the federal government has looked at what areas can be used potentially for wind energy. We're probably talking at, if we're talking offshore wind, we're probably talking at least 5 to 10 years before that would become reality. We do have the Amazon wind thing in the northeastern part of North Carolina. And so in the nearer term, there's probably more prospects for onshore kind of wind energy.
Since that link can't be clicked in the answers to the questions, I'll drop it in the chat as well for all viewers.
Thanks, Margaret. Oh, here we go. There's a link to the chat. The next question was Louis Goodell's question about how we can identify greenhouse gas emissions culprit and whether we can stop it. I don't know if there's anything else we want to add to that.
I really don't have anything, no.
All right.
You said this is a question by Louis Goodell?
Yep.
Yeah, I mean, we do have, I think, and David included, the state has done an emission inventory, so we know who's emitting what in the state. The harder part is getting programs and regulations and laws that will address each of those.
Thanks, Harvey. Next up, we have a question on how does the release of methane compare to the release of CO2? Does one have a greater impact on the environment?
Yes, in the short term, methane is a stronger greenhouse gas. As Colin mentioned, over a 100-year horizon, methane contributes 25 times as much warming as CO2, as the same amount of CO2 does over that horizon. So, and it's even worse on a shorter time horizon. So, overall, methane is a dangerous greenhouse gas that we need to pay attention to. The good thing is that, as you can see in this slide up, the concentration of methane is measured in parts per billion, whereas CO2 is measured in parts per million. So there's a 200 times less, approximately 200 times less methane than there is CO2 in the atmosphere, and we really need to keep it that way.
Yeah. If it's all right, I'd like to add a little bit of a perspective from the toxicology standpoint. Yeah, I mean, this is a similar situation with potency or toxin. If a chemical compound is going to induce a very mild adverse effect, it's going to take a lot for that to elicit effect in the body. But if something takes very little to generate a tremendous effect, that's what makes that compound more potent. And I think that's actually, that brings me to a question that I was wondering if you can address. So is it not more accurate to determine exactly how methane is going to affect our ability to address climate change? Why is NCDEQ using the measurement based on CO2 equivalent and not looking directly at methane itself? If you understand the question.
I can't answer that question. They should be looking at both. The CO2 EQ accounts for methane's stronger impact over the horizon, you know, so the carbon dioxide equivalency is meant to make gases comparable on an equal basis in terms of impact on the atmosphere or on the warming. So I, in my opinion, they should have a methane emissions target as well, but they don't.
That is something to think about. Okay, next question we have from Mary Gherkin. A friend said that the raw material and disposable of batteries and wind turbine has worse consequences than current energy sources, plus that we can't make enough energy through clean means. Who would like to answer that question?
This is Harvey Richmond again. One, I've not seen any evidence that that's the case. I mean, there's lots of people repeat things over the internet in terms of things being worse for wind energy. I've seen no evidence of that. Someone would have to, you know, submit some scientific, credible sources to make that argument. A group out at Stanford, you know, a highly respected professor in their institute, has done a study that showed for each state in the country that there is enough renewable energy and through energy efficiency to meet our needs. So that there have been studies that have been by university with experts that suggest just the opposite. You know, we have the technology to do it. It's a matter of whether we have the will and means to do it in terms of will follow through.
Thank you, Harvey. So we have the next question is, what are the top efforts being made to reduce carbon emissions in North Carolina?
Well, I think we talked about them. I mean, the Department of Environmental Quality has a clean energy plan that they are working towards. They haven't kind of revealed all of their details in terms of how they're going to accomplish their goals. Certainly part of it has to be putting pressure on Duke to stop building natural gas power plants and start building more solar arrays. The other thing then is also the conversion of 90,000 cars to complete electric, which reduces burning of the gas.
Yeah, I just want to add to what Dave, Harvey Richmond again, what Dave said. The top two things, and you had that chart that show it's energy and transportation make up the vast majority of the carbon emissions. And as Dave's already talked about the electric vehicles, the other thing is adopting programs like better public transit, which Wake County passed a new, put resources into developing a better public transit, reducing our miles traveled in addition to moving towards a more cleaner fleet. Both things are needed to reduce transportation.
Thanks, Dave and Harvey. And we have another question from Mary Gherkin. Conservation, it seems, is not something most humans are interested in doing. Is the only way to promote conservation is through a high tax or a carbon tax?
Yeah, I'll agree with her. It does seem to be difficult to understand why humans aren't more interested in conservation. And unfortunately, it seems like the only way you can get people to pay attention is for it to cost them money.
Yep. And we also have another question from Sheila Ditya. So this is in Maryland. We passed a 50% renewable energy portfolio by 2030 last year. The reason I ask about nuclear power is that it represents 40% of our energy. Since these plants may close around 2030, it's critical to develop a detailed emissions reduction pathway. Unless there's a very rapid increase in solar and wind, the goal of the 1.5 Celsius limit is probably slipping away. Offshore wind may be one solution for North Carolina, like in Maryland, but it is still quite controversial. This is more of a statement, but just wondering if anyone has any thoughts about this.
The only thing else is Harvey Richmond is that the Sharon Harris plant, which is the one that most impacts central North Carolina, including Wake County, I believe they've gotten an extension well beyond that 2030 timeframe in terms of from the Nuclear Regulatory Commission.
Thanks, Harvey. We have a question from Yvette Griffin Jr. Let's see. Has North Carolina reached out to companies in Germany in terms of how they are able to turn their use of wind and solar energy into a functional way of living without creating more issues for low-income communities? I know we're on different grids of a world map, but I was curious since it seems they've been able to reduce and contain most of the CO2 emissions as far as health and transportation. So I guess the question is, has North Carolina reached out to places internationally to see how they're doing with clean energy effort?
I don't know if they have. I agree with you that we should all share best practices across the world and learn from each other. But whether companies here are touching base with companies in Germany, or whether our state government here is talking to their equivalents in Germany, I have no way of knowing.
I was thinking of something along that line about Europe's effort for renewable, though. I mean, I don't know if Germany's involved, but I believe at least some parts of Europe is responsible for the shipping of wood pellets from the US to Europe for their energy consumption. So I'm not sure. So
That's been more case with the United Kingdom's involved with that, but the EU has not restricted England, UK from taking credit for burning wood pellets that are from cutting down trees in North Carolina. And it makes no sense from a climate, and they're getting credit for that for the climate programs in Europe. So the European Union is still partly responsible, but it's the UK that's actually burning it.
Yeah, that's not completely true. I mean, there are people in Netherlands and the Danes also are buying wood pellets. So it isn't just the UK that is being interested in buying our wood pellets.
Yeah, I wasn't really sure about the specific countries that's responsible for the wood pellet issue, so that's really good that you clarified that. Thanks. Let's see. Are there any other? Oh, we have another question. Have you heard of drawdown study, and number one issue are the air conditioner and refrigeration chemicals CFC, HCFC. Do you agree? Any air condition options, AC options currently available?
I'll take the first shot at that one. Yes, I am aware, and I do not understand why they have decided that that should be number one. If you look at this chart again, oh, I didn't want to do that. The CFCs and the HFCs on the left-hand side of the list are some of those are refrigerants. Maybe they're all refrigerants. But in terms of the radiative forcing, you can see how much smaller they are compared to the top three. So why have they decided that that's number one? I don't understand it. And I have tried to figure it out. I haven't spent a whole lot of time on it, but I am planning to try to at least get a better idea as to understand why they've focused on those as their number one thing.
Yeah, and another thing to add for this question is just that many of these chemicals do have a greenhouse warming potential that's 100 to thousands of times greater than carbon dioxide, but they are often released in such small quantities that their impact is nearly negligible on warming and just cumulative emissions that we see each year.
Yeah, that's true.
So I have a follow-up question on air conditioning and refrigeration, if that's all right. So would you say that the concern with air conditioning and refrigeration is more of an energy consumption issue than a chemical-related issue?
That may be, but that's not how they stated, because they stated in terms of how many gigatons of CO2 equivalents they are going to prevent from being emitted into the atmosphere because of changing the refrigerants, and or unless they're gonna, you know, I don't know what other alternatives in terms of a refrigeration process there are. So I don't fully understand how they're going to save all of those gigatons. I mean, certainly air conditioning draws energy, but if that energy is being generated through solar panels, then that goes away, right?
Yeah, that's a thought. Got a question
They say
about,
propane and ammonia.
is this in reference to the air conditioning question? Let's see. All right. If there's no more questions, actually, I have one other question I'd like to direct to Harvey or Dave or Colin. Most recently, I came across a news about how Microsoft is committing to carbon negative commitment. Just curious, would you be able to provide some example of what it means to be carbon negative rather than just carbon neutral, if possible?
Carbon negative, I believe, has to do with sequestration, sucking the carbon dioxide back out of the atmosphere and concentrating it and then storing it somewhere so that it can't get back to the atmosphere. There are companies and there are research being done right now to try to figure out how to do that. You know, when we say that we want to be carbon neutral by 2050, some of the plans, depending upon how much emissions you feel like you can remove through sequestration, allows you to keep using coal or oil or natural gas. And there's a lot of risk there because those technologies are not proven. We don't know how to scale them up and do it economically. So, you know, it's a risky proposition to place your future on the hands of unknown and unproven technology, basically.
I see the point, but if it actually works and we can actually have a reliable carbon negative technology, I think that would actually be very helpful, I think. Yeah.
Yes, but it shouldn't be, oh, that means we can keep burning fossil fuels.
Right, absolutely.
It should be, oh, we're going to use this to help get the carbon and the other stuff out of the atmosphere so that it doesn't get any worse.
Right. I mean, that basically is what keep it in the ground means.
Yes, exactly.
Yes. Yeah. Okay. It's 8:20 p.m. if there are no further questions, I would like to take this opportunity to thank Harvey and Dave and Colin for making this evening possible. I would also like to thank our staff member Margaret for assisting us with the technology and the logistics. We couldn't have done this without everyone being here today. And I thank all the audience for attending tonight. We will have the recording available. We'll let you know on our Facebook and also our meetup. So keep an eye out for those. And we look forward to seeing you in future meetings. Have a good night, everyone.